Here's a very quick video on this process called completing the square. Now if you're watching this, you might be in an Algebra 1 class or an Algebra 2 class or even a pre-calc class. Maybe you're in calc or even in college and you kind of forget how to do this. So it's going to be really quick. I'm going to go through two examples and then I'll show you where you would ever have to use this to sort of apply it to a bigger idea. So first and foremost, I'm going to start with a problem where I give you, this is a quadratic with some sort of missing constant term at the end. All right, so normally we see these in ax squared plus bx plus c, where we have to figure out this c. And we have to figure out a c that makes this into a binomial squared. So it's going to be, our goal is to get it to be like x plus or minus, something squared. Right? C is probably not the best term to use there, variable to use there, but plus or minus something squared. So let's figure this out. The way to do this is we have to look at that middle term, that b term. We have to look at this term right here. We have to cut it in half. So negative 12 over 2 is negative 6. All right, and then we have to square that. Negative 6 squared is 36, and I'll put that number right here. Now, what this actually turns into, if we factor it, and I'm going to assume that you know how to factor, if we factor this thing into two binomials, we have x and x, 6 and 6, minus and minus. And you can check that by foiling. And you, of course, see that it comes out to be exactly what we started with. Now, we don't want to waste paper, so let's write it as this binomial squared. So what I did was I turned this thing into this thing. It's kind of a nice little process. It's useful in a lot of different things. Number two, pause it, see if you can figure this one out on your own. I'm going to look for the c value right here. So I'm going to cut the middle term in half, and I'm going to square it. And I'm just going to simply turn this into r plus 5 times r plus 5 quantity. So I get quantity r plus 5 squared, and I'm done. This is a quick example of where this might be useful. Right, we're looking at a quadratic here, and maybe you're doing a problem where you need to figure out the vertex of this, and let's say you didn't even have a calculator. Right? So we want to figure out the vertex of this parabola. The parabola looks something like this. We want to figure out the vertex of it. In order to do that, normally we would probably go to our calculators and just figure out the minimum point there, and it's pretty simple. But for this example, let's assume that we can't use a calculator. So we're shooting to get this parabola into vertex form. Now vertex form is a little bit different than the standard form, and it looks like this, where our vertex is h comma k. So we need to somehow get this equation to look like this, from standard to vertex form. We're applying this completing the square idea. So here we go. I'm going to write x squared plus 10x. I'm going to leave a space. I'm going to write plus 24 over here. All along, I'm not going to change the value of the function. I don't want to change exactly what the function is. I just want to change how it looks. So we're going to figure out what thing to put in here so we can actually turn it into a quantity or a binomial squared. So we need to kind of figure out this blank space like we did above. So again, we're going to cut that in half and we're going to square it. So we're going to go plus 25. But since we added 25 to this function, we don't want to change the value of it. So let's subtract 25 to preserve our equality. Plus 25 minus 25 cancel each other out. So we have to do that in order to preserve exactly where we started. Now what I'm going to do is I'm going to group those terms together and I'm going to factor them. So it's x plus 5 quantity squared minus 1. So I just turned this quadratic from standard form into vertex form, where my vertex is -5 comma -1. Let's go to our calculator and confirm that, just to make sure that we're all on the same page here. I've got my calculator up here, and I want to go to y equals, and I just simply want to type in x squared plus 10x plus 24. Is that the right one? Yeah. So I'm going to graph that, and I'm going to see that my vertex is -5, -1. So I'll go to second trace. I'm looking for a minimum left-hand bound. I'm going to go to the left of my minimum point. I bring my cursor all the way down. So it's to the left of that. And I don't have to go quite that far, but there we go. And my right-hand bound, I'm going to give my calculator a nice window to look into. And that should do, and then a guess. And it turns out that I was right, -5 comma -1. What I like to do, just to sort of double check, is to make sure that the equation that I came up with, which is right here, I want to make sure that that is equivalent to what I started with. So I typed that one in as well. And I might go over here and I put a little tracer on it, change the style of the graph just so I can get a better visual. So I press enter a couple times until I get the little comment, and let's see if these should graph right on top of each other, and they do. So there you go. That's one application of how completing the square is kind of important. And if you want to pause and try this one, I'll go through this one very quickly. So we're trying to find the vertex of this, right? And our vertex form is a, and then the quantity of x minus h squared plus k. In this case, we have to first, what I'm going to do is first factor out, just out of the first two terms, a 3. I'm going to leave a blank. And in that blank space, of course, I'm going to cut my middle term in half and square it. This time, instead of subtracting a 4, it's technically not a 4 because there's a 3 multiplying it. So it's technically a 12. So if I want to counterbalance this 12, I have to counterbalance it with a -12. So I've got 3 quantity x minus 2 squared minus 108. So now I can see that my vertex is 2 comma -108, and there's even an a term here, which means my parabola is going to be a little bit skinnier. And again, use your graph to confirm. So it was a pretty quick video there. I hope that helped you. It was completing the square video that also led into this vertex form application. Thanks for watching, and subscribe.